We're going to look at common factoring, and this is a relatively complicated common factoring question. What I want you to notice, okay, is that this, it's easy to see this as a term and this as a term, but really they're multiplied together, and a lot of times in math we consider that one term within itself. In fact, what separates terms for us is either a plus or a subtraction sign. So this in itself can almost be considered a term. We can expand it and make it many, many more terms. But right now I want you to look at it when things are multiplied together, that's a term and that's a term. Okay, almost like the idea of if I was to say that this was like 3x, because they're multiplied together, that's a term, minus 5x squared. Though the variables are different, they're multiplied together. You can kind of see it as two terms, okay? So when you see things that way, it might be easier to see this as a common factoring question because there is a common term in here. Like there in the above example, there is a common x. We can kind of factor out a common x. Here we can factor out a common x minus 2. Okay, we can technically take x minus 2 out of this whole thing. Now, there are a couple ways to do this. Sometimes it's easier to see this idea by putting a let statement and turning this into a single variable. So I'm going to solve this kind of two different ways. On the left, we'll do it the large way, and then on the right, we're going to build a let x minus 2 equal y statement, and we'll rewrite the equation. Okay, so we'll kind of split this guy down the middle. And our equation on the right, the green one, will now read, same idea though, 4x, but now x minus 2 is just y, so times y, minus 3x plus 5, this whole thing here becomes y, okay? Actually, let's do the one on the right and then we'll do the one on the left. So now that we have that, it's a little simpler to see that y is a common variable here, so we can divide both these terms by y. Okay? In other words, we're factoring out the y value. Okay? So when we factor out our y value, y becomes the common factor, and what's left in brackets is everything that wasn't factored out. Well, the 4x wasn't factored out, the negative sign stays, and the bracket 3x plus 5 was not factored out. So all of that stays, the y's both move to a common factor on the outside. And if you were to distribute them back in, you'd end up with a y here and a y on the outside of this, okay? So now that that's happened, and the reason this is complex is because it looks like we still have like a couple brackets in here. Well, we can kind of simplify what's within those brackets. I'll keep this as a y, I won't change it yet, it's still a y. In these brackets, I can distribute the negative that negative value. Think of it almost like -1. So I still have 4x. This becomes -3x, and this becomes -5. Do you see that idea?
Yeah.
Distribute? Great. And now I can actually collect two like terms. 4x minus 3x. So we have y. 4x minus 3x just gives us x minus 5. I'll put these back to the curly or the rounded brackets here. Great, and now it's common factor. It looks good. The only thing is y wasn't what we started with. We originally had x minus 2, so we now need to replace that y with x minus 2 times x minus 5, and we'll write it all in black here, but this would be considered the factored or the common factored form, x minus 2 and then x minus 5. Okay, so without putting the let statement, let's see if we can kind of duplicate that idea. So in this version, we've factored out x minus 2. So the x minus 2 kind of drops out, and the x minus 2 kind of drops out. And inside the bracket, we have 4x minus, bracket again, 3x plus 5, and end bracket. And if you notice, this statement and this statement here are like identical. These two are the same. The only difference is here we have a y, here we have the actual value, so we don't have to do that substitution at the end. We already know that we can simplify inside these brackets, right? So we have x minus 2 on the left, and within these brackets we get 4x minus 3x minus 5. That simplifies into the idea of x minus 5. And on the outside we have x minus 2. So, though we took a couple more steps, and I did every step here, both methods take us to the same answer. Just a little bit more complicated of a common factoring question.